is Deep Time Detective, and today we're solving a mystery: the billion-year rust.
All right, we are going way, way back in time for this one to solve what is basically a planetary murder mystery. And the weapon? Well, it's a gas that you and I breathe every single day. The crime scene? The entire planet Earth. This is the incredible story of the billion-year rust.
I know, that sounds like something straight out of science fiction, but it's not. This is the actual geological truth of our own planet's history. It was an event that completely reshaped our world, and it all kicked off in an environment that would be totally, utterly alien to us today.
So to really get what happened, we have to travel back about 2.5 billion years. And I really need you to just forget everything you think you know about Earth. Because the planet we'd find back then, it was a completely different world.
Just try to picture how alien our own home was. The sky wasn't blue, not even close. It was this sickly orange color, all thanks to a thick methane haze. The oceans weren't blue either. They were a murky, bruised purple-gray color, completely saturated with dissolved iron that had been seeping out of the crust for ages. And here's the kicker. There was pretty much no free oxygen to breathe. Anywhere.
You know, every good mystery needs a culprit. And in this story, our prime suspect is microscopic. But don't let its size fool you. It was about to change the world forever by unleashing a brand new, and at the time, extremely toxic weapon.
So, meet Cyanobacteria. These tiny little organisms figured out a revolutionary new trick: how to harness sunlight for energy. We call it photosynthesis, of course. But this incredible invention had a byproduct: a waste gas that was totally new to the world: free oxygen. And for almost all other life on Earth back then, this stuff was pure poison.
And that right there sets up our central question. You've got this new, highly reactive, toxic gas being pumped into an environment that is just full to the brim with dissolved iron. The answer to what happens next? Well, that's where our story really gets its name.
Now, this wasn't some quick event. Not at all. This was a slow-motion chemical reaction on a planetary scale. It unfolded over a time frame that is, well, it's almost impossible for our brains to even comprehend. The entire world was about to rust.
So here's how it worked. It was basically a simple 4-step chain reaction. First, the cyanobacteria release oxygen. That oxygen immediately bumps into and bonds with all that dissolved iron floating around in the water. This reaction turns it into a solid particle. Yep, rust. And then, for millions and millions of years, a constant red snow of these rust particles just rained down, slowly settling on the ocean floor.
Just let that number sink in for a second. 1 billion years. That is how long this process, which we now call the Great Oxidation Event, just kept going. The oceans were literally bleeding rust for 1 billion years, slowly, painstakingly scrubbing themselves clean of all that dissolved iron.
And to put that timescale into perspective, this single geological event lasted for so long that it makes all of human evolution, all of our recorded history, everything. It just makes it look like a brief flash, like a rounding error. It's an absolutely humbling, profound scale of time to think about.
So, you're probably asking, how in the world do we know all this? It sounds like a fantastic story, for sure, but the evidence is real. It's physical. It's something you can actually go and touch today. You see, the planet kept a diary of this apocalypse, and it wrote it in stone. And this is the key piece of evidence. They're called banded iron formations. What you're looking at are these beautiful alternating layers of deep red rust and black silica. Each one of those red bands is a fossilized record of that red snow we talked about, a pulse of oxygen from cyanobacteria causing a massive rain of rust. The black layers, those represent periods with less oxygen when other stuff had a chance to settle. It's a planetary history written right there in the rock.
And this ancient event has a direct, and I mean direct, connection to our lives right now. These banded iron formations, they aren't just some geological curiosity. They are the primary source of nearly all the iron ore that we mine on Earth today.
I mean, just think about that for a second. The steel skeleton of the skyscraper you might work in, the bridge you crossed this morning, the car you drive. The iron in all of it is the fossilized remains of this 2 billion-year-old planetary rust storm. We have literally built our entire civilization from a microbial graveyard.
But hold on, the story doesn't end there. After 1 billion years, the oceans were finally cleared of all that free-floating iron.
But what happened next was a plot twist that almost ended complex life on Earth for good. It was a catastrophic, completely unforeseen side effect. See, once the iron in the oceans was all used up, there was nothing left to absorb the oxygen. So, for the very first time, oxygen flooded the atmosphere. And this new atmospheric oxygen immediately reacted with all that methane, the powerful greenhouse gas that was keeping the planet warm, and basically neutralized it. In what was a geological instant, Earth's cozy, warming blanket was ripped away, and the planet plunged into a deep freeze.
And when I say a deep freeze, I mean a serious freeze. This wasn't just your normal ice age. Scientists estimate that the average temperature, even at the equator, dropped to minus 50 degrees Celsius. The entire planet became a snowball, completely frozen over from pole to pole for millions of years.
So, what's the final verdict in this planetary mystery? What does all of this, the rust, the freeze, the sheer violence of it all, what does it mean for us, the inheritors of this chaotic past? The answer, it turns out, is profound.
The Great Oxidation Event was, without a doubt, the greatest extinction event in Earth's history up to that point. It wiped out most of the life that existed before it. But here's the incredible paradox. Without that apocalypse, the stage would never have been set for complex, oxygen-breathing life, for us to ever evolve. We owe our very existence to this catastrophe.
And this brings the whole epic story all the way back to you, right now. The very elements that make up your body are a legacy of these deep time events. That iron atom at the center of each hemoglobin molecule in your blood, the very thing carrying the oxygen you're breathing right now, is a direct descendant of the iron that once turned those ancient seas red. You literally carry the memory of that billion-year rust inside of you.
So if there's one final thought to leave you with, it's this. The story of the billion-year rust teaches us that life itself is a geological force, and that change is really the only constant. The cyanobacteria? They were the masters of their world, right up until their own success made that world uninhabitable for them. It is a powerful, powerful reminder from deep time that nothing, no matter how dominant it seems, lasts forever.
If you enjoyed this journey through deep time, like, share, and subscribe, and join us